Hi everyone, welcome back to my channel. Today we are going to dive into the world of atmospheric motion. So let's get started. First thing first. So let's talk about the pressure belts. Overall, there are these 7 pressure belts on the planet Earth. These are the regions in the Earth's atmosphere where pressure is relatively high or low. The movement of air from high to low pressure is due to the pressure gradient force. Pressure gradient is like a natural push that sets the wind in motion. But wait, there are more factors affecting the motion, that is the Coriolis force or effect. This force is the result of Earth's rotation and that causes moving air to be deflected in the right in the northern hemisphere and left in the southern hemisphere. So it is like a cosmic spin which deflects the direction of the wind in right in the northern hemisphere and the left in the southern hemisphere. When air moves close to the surface, it is also affected by the different objects. Like for example, behind me there are trees that also reduces the velocity of the wind as well as the buildings. Likewise, mountains can also act as a barrier which may deflect the direction of the wind and as well as may create the localized wind pattern due to reduction in the velocity and the change in the direction of the winds. So let us talk about some major players in the atmospheric circulation through these Hadley, Ferrel and the polar cells. These cells are like giant conveyor belts that transport heat from the equator towards the pole and which regulates our climate. Hadley cells operate near the equator, are responsible for those tropical trade winds we often hear about. So at and near the equator we have this pressure belt called the intertropical conversion zone, or in short the ITCZ. It is where the trade winds from the northern and the southern hemisphere meet. Remember, ITCZ also oscillate north and south with the change in season, and that is also responsible for the arrival of the monsoon during the southwest monsoon season in the South Asia. Now, as we move away from the equator towards the 30-degree latitude in both the hemisphere, we encounter another important pressure belt, that is the subtropical high pressure belt. Here the descending air creates high pressure at the descending section of the Hadley cell and the Ferrel cell in the middle latitude, and that also plays a key role in shaping the prevailing westerlies. Finally, polar cells operate near the poles and contribute to the polar easterlies, which collides with the westerlies and creates another weather phenomena that is known as the polar front. Lastly, let's touch a few factors that influence the pattern of wind. One important factor is the temperature difference between the regions. Warm air rises in the equator. Now you know that the cooler air sinks at the poles. So this pressure difference, temperature difference and the pressure difference create the pressure gradient force, which is responsible for the creation of the wind, and the velocity of the wind also depends on the differences in the pressure gradients. The more the pressure gradient, the velocity of the wind will be more. Now we know that since the earth is rotating, that is why we have 3 different atmospheric cells. And finally we have the geostrophic wind. This is a wind that flows parallel to the isobar or lines of equal pressure at high altitude. It is like smooth steady breeze, and that occurs when the Coriolis force and the pressure gradient force are in perfect balance. So that is all for today. Thanks for listening and watching. I hope you like my video. Kindly subscribe and thank you so much.